Here's a follow-on video to my one on register notify as a messaging pattern. I thought I'd show a little more about the value of using the state notifications. That's notification where the observer register little helper thing remembers the last message so that any new person registering can immediately receive the information they need. I also want to show how to treat messages more generically, because one of the problems with messaging is you've got lots of little things you've got to do to connect this to that and do different messages, and I want to show how you can treat many messages at once. So I'm using the original example just to show you it running. Again, it's a top level actor that when it launches an instrument actor, and the two are connected. So although the instrument, if you change something like the amplitude, it shows up in the top level. If you change the period in the top level, it shows up in the small one, and you can change, so they're all connected together. So the thing I've added is called the new user interface. This is dynamic, nothing is running right now. When I push this button, it'll create a new actor and register it so that it can communicate. So there's one, it's done amplitude and period, and you see it's joined together. In fact, I can make a couple more, and they are all slaved together. Everything is connected to the instrument actor. So any message you send goes into the instrument actor. The instrument actor then notifies everyone registered for the change. So all these guys are registered for the changes. So let's quickly see how this works. So here's my new control, call it a control server. And this is a standard template with 3 modifications. The first one is, because I want this to be temporary and shut itself down when it's not viewed, I've changed the panel close event. In a regular template, if the actor is not running top level means you started it yourself. If it's not running top level, it doesn't shut down, it just closes its front panel. That's because its caller will determine when it should actually shut down, not the user, by closing the front panel. Here, we want the user to actually, when it closes its front panel, it just wants to shut down. So I made that change. Then I've added some controls, the amplitude and period, but I haven't actually done anything specific with these. I'm doing everything generically. What I've done is, first I make sure my panel is open. I need that in order to do registration. And then I make a control lookup table. I find the panel, front panel, find every control on it, so all the controls on the front panel. Every one that's visible, because I don't want to use every control, every visible control, I record its a lookup table using a variant attributes. Based on the label name, I look up the control index and the reference. So basically this is a table where, given a name, I can look up the information I need later. And I also return an array of the visible controls as an array of references. So I take the array of visible controls and I register for any value change event. So any change of any one of these controls, well, both of them, both of them, but there could be 100. It doesn't make any difference. Any one of these things will become an event registration, visible controls, value change. And all I do is take that new value, which is a variant, because these are generic controls, and I post it as a notification, an event notification. Note that I don't even need to do the label, because these notify things will, if the label is empty, they will look and get the name from the variant itself. So if the amplitude changes, the variant will be called amplitude. If the period changes, it will be called period. So this is all you have to do in order to convert value change events into notifications. Then to get the messages, get the information coming the other way, coming into it, I've added one message to the standard set, a set control message. If the message is labeled set control, I assume that it contains another message. So it's basically an envelope that if you open it contains another envelope. The outer envelope says set control. The inner envelope, its label is the name of the control we're changing. So I look up that control and get the information, get the control index. And then the actual thing inside the inner envelope is the value. So I set that control by index. The reason I use this set by index is that it's faster than a property node. But you could use a value change property node or a value signaling property node. So that's it. That's all the code in this little control server actor. And now how is it called from the top level VI? In the top level, when you hit the new UI button, we call launch control server UI. That takes an instance of the control server. It's a shared reentrant, so we can have multiple. Launches it, tells it to show its front panel, and then it sends two registration messages. One we send to our new little actor itself. We register for what we want, amplitude and period. Sorry, wrong way around. Yeah, we register for amplitude and period. We register instrument 1 to receive these messages, these notifications. But if you look at instrument 1 doesn't receive amplitude and period. It receives set amplitude and set period. So we use message translation to configure this address such that it always adds set to the front. So that converts them into the form that instrument 1 is expecting. Then we send another registration message to instrument 1 for the same information. And here we want to configure it so it's what the control server expects. It expects an outer envelope labeled set control. So here's a message translation where we add an outer envelope labeled set control. So we send these two registration messages off. Because amplitude and period are state notifications in instrument 1, that means that as soon as instrument 1 receives that registration message, it will immediately send the latest amplitude and the latest period. It's so fast you can't even see it. It's already done by the time the front panel is open. So let's see it run again. So if I run this and I change the amplitude to 1.23 or 1.23, and then when I hit new UI, they are immediately at 1.23. And that's actually because it's received the notification so fast that you can't actually see it change. We could probably, can we? Let's see. If I took one of these and I put my probe on here, custom probe, message cyclic table. Oops, that's dangerous. There's something in LabVIEW. It's got some kind of bugs about custom probes. So, oh, did I just close it? Darn it. Let's try it again. Are you going to give me the same error message? Yes, you are, but you're going to work. All right. Fine. Right, let's run this. When I hit new UI, it's not going to work. Try it again. All right, there. Now we started this one. Again, we get the self-initialized message first. Then we receive show front panel. Then we get register for multiple labels, amplitude and period. And then we very quickly, within I think 1 millisecond, we get our initial set control messages from instrument 1. We set the amplitude, contents 1, and the period contents 100. So you see how fast it is. Because it's a state notification, you send your registration messages off and immediately it produces the information that you need to initialize yourself. Now, once we set up, the advantage of using the generic messages can be shown by making a change. I've deliberately left off frequency. So say in this actor we want to do the frequency as well. So we've got a pre-existing frequency control. We'll drag it over. And we'll run. And we'll start a new UI. And now we can change the frequency. No, we can't. We spelled it wrong. Damn it. I was sure that was going to work. All right, let's see. What have we done wrong? Oops. Get to the actual one. What have we done wrong here? Let's see. Let's have a look. Let's just run it and diagnose what the problem is. Oh, I know what the problem is. Now, this should be instructive for you. I've got to actually register for frequency. There we go. Let's try that. And now you work. Hey, okay. So yeah, now you can see that it works. You have to actually remember, it's not not 100%. You have to actually remember, you've got to actually register. That's because it shows that the top level, the thing that is calling the code, is in charge of what actually gets sent. It's the top level that's responsible for connecting instrument 1 and the control server. Control server doesn't know instrument 1 exists. Instrument 1 doesn't know the control server exists. It's the top level that creates them both and connects them with these registration messages. So actually that mistake of mine actually shows an important point. Because by not doing this, control server is much more reusable because it doesn't actually know the thing it's talking to. It just knows that I receive these messages and I send these messages, and the same for instrument one. And the top level is much less reusable because it's really specific, but it's one thing that sort of like uses their more reusable components, hooks them together. It would be relatively easy to reformat things and switch them around because the things, the components the top level is using are much more, they snap together. Anyway, so those are two things that I want to show, the how you can dynamically create an actor, hook it into the existing state notifications very quickly, and also how to treat messages much more generically. So in your control server, we've only got 3 controls now. You could easily add 50 controls, and you could treat them all generically. This kind of setup is also useful where you look up things by name for connecting your messages to any kind of name value system. So for example, DACMX. You can have DACMX channels. They're identified by name. They have values that are variants. It's very easy to connect messages to DACMX channels. Or in iMac, cameras often have attributes. They're also name value pairs. And you can very easily hook those up into a messaging system as well. Anyway, thank you very much. Here's a quick added note I've added later. When I made the mistake and didn't have the frequency, I wanted to show how, or make another couple of points about this. One is that it's actually kind of a weakness of doing things this way, that because instrument one and the control server don't know each other, they also don't know if they're not properly hooked up. It's the responsibility of the top level to actually hook them up correctly. And the top level doesn't immediately know if there's a problem either, so it can be difficult to debug, and I want to show you how to debug these kinds of things. So what I'm going to do is, before I didn't put frequency in, here I'm going to do something even more insidious. I'm just going to not capitalize frequency. Unfortunately, things like notifications are case sensitive. I've considered changing that, but at the moment they're case sensitive. So what if I made this little bug, I made an error, and I ran? How would I discover it? So I start top level. It's working. I start a new user interface. Period works. But when I do frequency, it doesn't work. And I say, well, what's wrong? So the quickest way to do it, which I didn't do before, look at the block diagram, and you have to ask. There's 2 special custom controls. One is the custom control to look at the messages coming in, and the other is a custom control on the observer registry. So let's do that one. So let's see. Ooh, it's not working. I'm on the wrong one. So that seems to work. So I registered the 3 things: amplitude, frequency, period, and frequency. I wouldn't notice yet that that's wrong. That seems fine. So let's go look at the instrument. Here I want to look at the observer registry. That's some kind of LabVIEW bug. It doesn't like custom probes. Here I look and I go, what? Wait a minute, there's frequency, and I've got 1 thing registered. Reading, period, I've got 2 things registered. That's the event messenger, that's the top level, and then there's the control server. You can see it relabels. And then I've got another frequency, the control server registered for, and this does no data. So the frequency has information in it. The frequency with a small f doesn't. So this is where the point where I would realize my problem, because I'm registered for the wrong thing. I'm not registered for frequency. I'm registered for period, but not frequency. Instead, I'm registered for frequency with a small f. So that would tell me what the problem is. That's the point when I would stop, go to control server, go to my main thing, and figure out, oh, there we go. Then I would change it, fix my bug, start again, and it would work. Anyway, so that's what I'm going to show. So again, it's a weakness of the library that you can sort of mistakenly hook things up and you don't realize it because the components don't actually know there's a problem, but you have the custom probes that allow you to quickly figure out what you've done wrong. Thank you. Goodbye.